This is a quick overview of the Inventa discovery and classification sensitive data intelligence solution. It's going to be very condensed, just a 10-minute overview. If you have interest in learning more, please reach out to your one-touch sales rep to have a deeper conversation regarding Inventa discovery and classification sensitive data intelligence. Things start at the network layer. This is a network-based approach to discovery and classification. There's many options. There's a discovery at rest component, and there's a discovery in motion component. There's many options to crawl data sources. I'm going to start off with the assumption that an organization will be utilizing the network of visibility infrastructure within an organization to feed into the Inventus solution. So with that, the system is able to read transactions over the wire. These are specific data protocols, for instance, JDBC, Kafka, SMB. These are all protocols that the system will listen and sample over the network, and based on that, build a topology of transactions as they are occurring in the moment. So we have a visual of clients and servers that are interacting with each other, and these can be filtered in a number of different manners. If you wanted to see with the transactions in your DMZ, your external or your local area network, you could simply filter the network map to have a visual of the transactions as they're occurring. We have candidate, PII, data subjects, which I'll get into in a few minutes, but there's a number of different ways you could filter this, and you have a more of a line item view of the different nodes on the network that are transacting data sources. So once an inventory of data sources are automatically populated, we could then begin scanning and analyzing the data sources at rest. So the system is designed and built, comes with out-of-box classifiers. Organizations can add their own classifications and configure it to meet their needs. Example right here. So we have a credit card number. Organizations can add their own classifiers, tag it to a specific regulation. There's a number of different configuration options that are here, whether you want to inventorize the actual record, encrypt that record in the Inventa catalog, apply pre-formatters, which account for the spaces and hyphens and periods in between the record level, add keywords, patterns, functions, or dictionaries of values, or specific language settings for a particular classifier. So a number of different options at that first classification level to configure the system. And then the system, as it's doing its data discovery, for privacy use cases, it's going to see if there's enough information to build digital profiles. That's done utilizing constraints. An example here is for privacy use cases, the system will leverage the constraints to build digital profiles and delineate between 1,000 John Smiths or 1,000 Jane Smiths, for example. First name and last name is not enough of a constraint to delineate between 1,000 John Smiths or Jane Smiths, but first name, last name, city, and street address would be for the confines of an organization's data sources. So once that's began and the system has already inventorized a list of data sources, we could begin crawling the data sources at rest. You could see we have an inventory of the data sources that were auto-discovered over the network. Data sources can be imported manually via CSV or an API, and analysis windows can be configured to meet the appropriate scanning windows for an organization's. Scanning windows can be configured per analytic engine, per data source type, per data source product. It could also be done leveraging tags. And once the data sources that meet the specific criteria are populated, you could then specify analysis window. In this example, we have Thursdays and Saturdays as the analysis window between 4:30 and 7:30 a.m. So what happens at 4:30 a.m., the system begins its crawl of the data source. At 7:30 a.m., the system essentially pauses the crawl. It will remember which record it left off on, and during the next permissible window, it'll pick back up where it left off. So once initial scans are done, the system is going to present candidate PII bubbles. And we have a supervised AI wizard that allows data professionals or really non-technical professionals to build fairly complex training models without having a pure data scientist background. So I'm going to walk you through an example. So the assumption is we've conducted a few initial scans. The system is going to present these candidate PII bubbles. Me as a user can look at any one of these bubbles and analyze the contents of this candidate PII bubble. It has 33 million candidates. And what we're looking at here is the view that the system built based on the root table. And the system made some assumptions based on the constraints that this root table has relationships with other tables as well. A user can come in here and modify that existing relationship to really pull columns from multiple tables into a view that's meaningful for the organization. Once that's done, we could preview these sample records that's associated with that view. These are the fields that are in that view. These are the data elements that are configured in the Inventus solution. If any one of these classifiers needs to be remapped for any particular reason, we can simply click on these three dots, edit this classifier. We have a field here, we have a data element that was mapped to, and we can correct the mapping if necessary. So once this view is created, I could then take these records, the records itself, and build training models based on that, and scan for copies of these records in other areas of the organizations, thousands of other databases, petabytes of other unstructured data sources, emails, chats. The coverage is really broad in terms of what we cover for discovery and classification, but it's going to know it's looking for these specific records. So what I could do is mark this as a root data asset, which is essentially a training model. I'm going to, for example, I'm going to mark this as my European subsidiary. This is a table containing my EMEA customers. I'm going to save it. I'm going to click on Valid Virtual View. And just like that, I have a training model based on that particular view that I created. So now what I'm going to do, if I want to understand how that particular data set is being managed by the organization, I'm going to create a data asset called European Customers. I'm going to click Edit, or I'm going to create a new data asset, and I'm going to map it to that view that I created. I'm going to file my reasons for processing. I'm also going to apply any tags that are associated with this view. Customers in Europe is going to be a tag in itself, but I could also apply additional tags as well. Mark that data asset being belonging to customers or employees. And now I could have a view of how European customers are being processed throughout an organization, both at rest and in motion. So if I look at rest, I could see where those specific records are existing in all the data source types in my organization, anywhere from emails to unstructured repositories to structured databases, the product vendors that are processing European customers, and the specific file types. And I could even go down and drill down and start sampling some of the data sources and the records associated with it by simply clicking on this arrow and sampling some of these records. So we also have this view as it pertains to InMotion. And now I could have, again, I have my data sources that are transacting those InMotion, the product types, the files that were transferred. I can click on any one of these. I'm going to click on a CIF share. I have the transaction time. I have the transaction client, the server, the port that initiated the transaction, and the number of data subjects in it. And again, I could look at some metadata around that transaction. These are the classifiers that were in that transaction, the categories. And again, I could sample some of those data subjects as well to see what types of records are in there. So now, if I wanted to look at some of the dashboards that are available, we have security-oriented insights and data privacy-oriented insights. We have a security lens that gives a security status. and some insights regarding what types of sensitive data were discovered, what they may be in scope for, and I could drill down and actually take a look at any one of those data sources granularly. We have a privacy view that gives an organization what types of privacy regulations are in scope, which data sources contain the most amount of data subjects, and also a distribution based on category and data elements, and understanding where those are broken down by schemas, tables, and columns. I also have a risk view that gives an organization more of a global view. These bubbles right here represent where analytic engines are deployed, and we could see how many data sources are in scope there, drill down to get a more granular view of what's in those data sources. We have the ability to do classification searches. If I wanted to search a data source for a specific data element, I could do so. I could say I want to know all my data sources contain a credit card number that are in scope for European customers. I could search by tags. I could search by data assets. I could search for a particular data source type or URL, a specific vendor. I'll click search, and it'll pull up all these applications or data sources that the system has uncovered and started scanning. I could drill down and get a more granular view of what's contained in those data sources. Everything's broken down by schemas, tables, and columns. I have a data element breakdown of where each data, where the data elements are, how many schemas, tables, and columns are being processed. And if I wanted to filter that, I could ask the system to tell me where every credit card number is in every schema, table, and column, and export this for remediation. Our privacy-oriented module is really designed for a key few use cases, DSAR being a very core one. If an individual calls in and wants to exercise their right to be forgotten, the system, based on those constraints, are going to build digital profiles on the individuals that it's identified. It's marked as trusted if this data element was found in the supervised AI engine. The system will also tell organization if they're holding conflicting information regarding an individual. If this individual created two different accounts, he used his same first name, last name, city and street address, just used a different email. He may have two club customers ID. The system is able to stitch together and tell an organization if there's if they're holding a data element that should be unique for an individual, but there's two found. We'll mark that as conflict. We'll show exactly where that conflict information is found. But also, the system will also mark certain data elements and records as discovered. If it wasn't verified against supervised AI, but perhaps discovered in an unstructured file or unstructured repository, the system is able to stitch together and figure out that these emails, the email and the phone number was associated with Donald Miller. And then we have a copy where where this individual exists. The RDAs are those supervised AI models where this individual was trained from. And then we have transactions that are associated with this individual. We have files that are associated with this individual, the path to get to the file name, the information that's contained in that file, databases where this individual exists, what data asset. He may be a customer. He may also be an employee and a loyalty club member. We'll file which data asset that individual belongs into, but we also have coverage for emails if his information is being sent via email. SaaS application communication platforms like Slack or chat, notes, and cloud object storages as well. So that concludes this short demonstration on the Inventa solution.